That looks kind of scary.
It does. That's why I stopped the video so we can talk about it together. The standard deviation formula, there's something called variance and then the standard deviation. It tells us how closely the data is to the mean. So basically, when they give us a standard deviation for a data set, we can see how spread out the data is. When we get the PSAT scores from the PSAT you guys took, we will get an average and we'll also get a standard deviation. And that's because the standard deviation lets you know how spread out the data is. Okay? And so one way that we can find standard deviation is to compute it using this scary formula. Notice there are two formulas. One if you have a sample data, one if you have a population data. The only difference between these two formulas is whether you divide by n minus 1 or n. Everything else is the same. They just use some different letters. So I have that up here. I can talk about the video, but I'm going to say it again. X bar, or this little symbol here, which is called mu, that's a Greek letter. Math people love Greek letters. Those both just stand for the mean of the data. Okay? This symbol, which is sigma, that's the Greek letter, but it just means the sum of. So whenever you see that symbol in math, it just means add it all up. And notice, they both, like this stands for standard deviation. If you have a population, this also stands for standard deviation. This is lowercase sigma, this is uppercase sigma. There's upper and lowercase of all the Greek letters. But what this says we're going to do is we're going to take the square root of taking each number minus the mean squared, and we're going to divide that either by the number of numbers minus 1 or the number of numbers. So I had an example here. I really stopped at the mean part because I want us to practice doing this. It's kind of tedious, and then I'll show you how you can use some technology next week to do this as well. I also want to say you don't have to memorize this formula. I'll give you the formula, but you got to know what it means, right? Like when you just look at it, you got to know that means add it all up. You got to know that means the mean. So if you look at this example, it says the daily high temperatures in degrees Fahrenheit in a city for the first 10 days of last year were these temperatures. And for the first 10 days of this year, they were these temperatures. It says find the standard deviation for the first 10 days of last year's temperature. So last year's temperatures are using these numbers. And this is where I stopped in the video of step 1. Every time you're going to find the mean of the data. They say this is a population, not a sample. How do we know? Because we have 10 days of temperature and we're using all 10 days. If we were only using 5 of the 10 days, that would be a sample, not a population. So because it's a population, that's how I know I'm going to use the formula for population. And then it just says the mean was 50.6. How did they get that? And you can practice on your calculator if you want. How do you do the mean of a set of data? You just add all these numbers together. And you divide by the number of numbers. So on the calculator, if you take and add all those up and you divide by 10, you should get 50.6. So if you add them all up, you get 506 divided by 10, you get 50.6. So that's step 1. You got to find the mean. Step 2 is, so step 1, we found this number. Step 2 is we got to do this top step, which means we have to take each number minus the mean and square it, and then we have to add them all up. Okay, so I'm not gonna write every step of this down because we're just gonna do it on the calculator, but I'm just gonna go back up here. So I'm gonna take 38 minus 50.6, and I'm gonna square it. And I have to do that for all 10 numbers. I promise. On the test, I won't even give you 10 numbers. It's too tedious, right? Like I would give you like 4 or 5 numbers to do because it does take time to do it. But then I have to take 48 minus 50.6 squared. And I like to do this top step all at once, and that sigma means I'm going to add them together. So I'm going to put a plus sign in between here. 51 minus 50.6 squared. And then I'm just going to put dot, 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 because I'm not going to write all that down. I'm going to do it on my calculator. But I'm going to do that for all 10 numbers. And I'm going to end with 36 minus 50.6 squared. And when I do all of that, that's going to be the top of that formula. So what I would like you to do is grab a calculator and practice typing this in. There are strategies to do this, okay? For me, I just try to type it in all at once. I will tell you there's a limit of how many characters you can put in, and sometimes you have to hit enter and then keep going. Some people don't like the stress of typing it all at once, so they do one at a time, and then they write those numbers underneath, and they add them together. So you have to decide what works for you. So if you don't want to do it all at once, you could just do 38 minus 50.6 squared, and then you could write that number down, and then you could do the next one and you could write that number down. So the big part is just typing it all in. It takes some time, right? So let's see. I'm going to do it too. Make sure you use your parentheses, you use the squared button. Pay attention to the line at the top, because I do think you're going to run out of space at some point. Man, I already messed up. Oh yeah, so after 53, if you get to this one, your cursor looks really weird. It's not going to let you type in the whole next thing. So when I get to finishing 53, I'm going to hit enter, and it's going to add those up, and then I'm going to hit a plus sign again. So let me know if you need help with that. See if I feel good about this. I got 966.4 as my number.
Yeah, I only got like halfway through.
But keep going. That's why I'm just stopping. But you can keep going. So that if you don't get it, then I can see who messed up or if I messed up. Well, that's not. Did you have run out of space? Like, did you run out of space like I said and you had to hit enter? Oh. Or is anyone writing them down one at a time? That way, some people really like that, because then they don't have to worry about where did I mess up? So you can do each one at a time, write those 10 numbers down.
Like writing all those numbers down is just too much. Or like typing all at once. It's like making an issue.
Right, if you make one mistake, you got to go back and find it.
I got so close to the end before I had to.
Yeah, and then you just hit enter and then pick right back up and just hit enter and then plus, and it'll take that answer and keep adding it. Yeah, I got 966.4 both times. I did it, so. I already did it twice. I know.
I'd say I went wrong somewhere.
You didn't get 966.4?
I got almost 4,000.
Oh yeah, that seems wrong.
Yeah, it's
Hold on, I can look at it. Don't clear it out and I can look at it.
oh, too late.
Oh. I can't help you where you messed up.
I tried to type something wrong. It's somewhere.
Yeah. That happens.
So,
Did you get 966.4? Anybody else get 966.4?
I'm kind of sketch that.
I might have to go through and do them one by one.
We're gonna look next week, like definitely we can do this by hand, but when they look at standard deviation for like all the people that took the PSAT, they're not computing this by hand. They're using like a spreadsheet, and we can use a spreadsheet to do this formula for us. But this is just the tedious part of doing it by hand.
What you get?
966.4. And then, like, what we just did, that's that ugly part of that formula. And now we just divide by n, which is the number of numbers in the data set, which in this case there were 10 temperatures. And then really we can type that in all at once in our calculator, or if you want to do 966.4 divided by 10 and then do the square root of it, that works as well. When we have a test, I always recommend, like, show me these numbers before you just type it in the calculator, so in case you don't get the right answer, I can see, like, at least what numbers you have. On my calculators, if you do the square root button, it automatically puts a parenthesis. Just don't close that parenthesis until after you put the 10 in there. And what we get is, we're going to go to 2 decimal places. We get 9.83 as the standard deviation.
Yeah, what was the percent? I think I forgot to add 1%.
Yeah, it's just tedious, right? So what does that mean? Well, it's hard to tell what it means when we only have one standard deviation. Usually we're comparing different things. What you're going to do for your homework in a minute is answer a few questions, but you're also going to go back and you're going to do the standard deviation for these other 10 numbers, and then we can compare looking at the standard deviations about which ones had more spread out data. And so in a minute when I show you the assignment, when it says go back and do the other 10 days, that's from this example, okay? But really quick, what does that mean? It says in a given data set, the majority of the values will always fall within one standard deviation of the mean, and almost all data will fall within 2 standard deviations of the mean. So what we just found on the last problem, we found the mean was 50.6. So the average temperature last year was 50.6. And we found that the standard deviation was, what was it, 9.83. So if we take 50.6 and we add the standard deviation once, and we subtract the standard deviation once, you will get that almost all of your data will fall in that range that we get. So if I take 50.6 plus 9.83, I get 60.43. And if I take 50.6 minus 9.83, I get 40.77. So we can say, and we can go back and look at the data, that almost all of the data, all of the temperatures should be between 40-ish degrees and 60-ish degrees. And I'll bring back to this in a minute. And notice which ones aren't in that. Like 36 isn't in that. 69, 64, 38. So 6 of the 10 numbers are within that one standard deviation. We could do it again, but I'm not. But it says almost all of the data will fall within 2 standard deviations. And if we did that again, it would have all the standard deviations. So it says the greater the standard deviation, the more the data deviate from the mean, which means the bigger the standard deviation, the more spread out your data is. So when you get a really big standard deviation, it lets you know that the data is really spread out. So when I look at average scores in here, I should also look at the standard deviation to think about like how, like on the last test that we took, it would have had a very small standard deviation because so many people did so well
Sounds like a lot of work.
on that test. Well, there's a formula on that I can just type in the numbers and click a button on Google Sheets and it'll do it for me.
That's nice.
Which I'll show you next week. But I just want you to do it by hand, just to show you how cool it is. Okay, so here is the assignment that you're going to do. I'm not sure if it's in your packet. Is this in your packet?
No.
It is, if you turn the page. It's also posted on Classroom. So I will tell you, the majority of this assignment is not standard deviation. It's the other stuff in the video. So notice, number 11 just says, which measure of central tendency best represents the data? So given all these vegetables and their calories, like they just want you to say, they don't have to compute it, which would best represent it, the mean, the median, or the mode. So that's 11 and 12. And then 14 and 15 and 17 just says, is it a, I have this all covered up. Is it a population? Is it a population or a sample? So again, you're just looking at it and telling me, is it a population or is it oh no, don't look at the answer.
Population.
I'm trying to hide the answers here. Is it a population? Is it a sample? So again, not really anything to compute. The only two problems that you actually have to do math on, 21 talks about the margin of error, which is the formula in the notes. It says, what is the margin of error? And then find the interval using that margin of error. So that's a little bit of math to do. And then 22, maybe you want to start here since that's what we just did. I want you to go back and do the standard deviation for the other 10 temperatures and see what you get. So if you want to do that first so I can help you if you get stuck on it. But that's your assignment. There's no new video. So you have about 11 minutes in here, but whatever you don't get done, this is your homework for the weekend. Monday, we're going to go over it, and we'll do a little activity on Monday, and maybe look at doing standard deviation on the computer on Monday. Okay? Kaden, where's your notes packet, my dear? I really worry about you sometimes. So again, as you're looking at the first, if you're starting with the first ones, if they're outliers are like numbers that are like really far away, then that's where mean is not a good choice. If there's no outliers, mean is a good choice. So. You totally got these right answers, but you got the numbers wrong. So if you need help knowing how to do this, tell me, okay? Because you labeled them right, but then I don't know how you did it. Like, did you do it by hand? Did you have it in the calculator? I think you just multiply the numbers together.
I got it for that one. I was looking at it.
Because like if it's a combination, I don't really remember, but I think it was like 7 choose 3. 7 times 3, so you would do 7, go to this button, and since it's a combination, you go over to the C, and we're choosing 3. And then that's the answer. Yeah. And then this one, you're right, it's a permutation. I don't really remember the numbers. I think it was 9. And that's a permutation, so you go and put that, and I think it was 40. I don't know. But that's why I was like, you said it right, but then you didn't do the numbers right, so I just want to make sure. But yes, you do have to make that. Yes. So that means every element. Yeah. I haven't created your routine yet. You can retake that homework today. Alright. Maybe later.
I have one of the busiest homeroom schedules.
What are you doing in homeroom?
So Monday I had to go to
Oh my gosh, I'm still recording. I forgot.
Monday I had to go to Eric's.
Yeah.
Tuesday